This video is going to go through the Unit 5 Quiz 1 study guide. The first few questions are talking about excluded values. So remember, excluded values are x values that would make the denominator equal 0, which is not allowed to happen in a fraction. So to determine excluded values, we set our denominator such that it cannot equal 0, and we solve what we have. Typically, we're going to need to do that by factoring, because each factor has an excluded value that would send it to 0, and so we have to exclude them all. So for a trinomial like this, remember, we know that x squared is x times x, and then we need two values that multiply to negative 24 and add to positive 5. So that would be positive 8 and negative 3. So then each one of those is not allowed to equal 0. So x plus 8 cannot be 0, and then x minus 3 cannot be 0. It's the same zero product property we use to solve quadratics for their roots. We use for these excluded values. So if we solve this, x cannot be negative 8. And if we solve this one, we would add 3, x cannot be positive 3. And those are our excluded values, negative 8 and 3. Okay, for something like number 2, we have x's and y's. And so what we're going to look at, you could think of it that each x term, x monomial, is a factor, and then each y term or monomial is a factor. So if I look at each one individually, 3x squared cannot equal 0, and then y cubed cannot equal 0. So if we solve those, or even just think them through, the only value we could square and multiply by 3 and end up at 0 would be 0. And the only number I can cube and end up at 0 would be 0. So x cannot be 0, and neither can y. And remember that anytime you're looking at a monomial term, just a single term with a single variable, the excluded value is 0. Okay, here we're listing the excluded values for a division problem. So we have to first get the excluded values for both denominators as they are. So to factor this denominator here, to multiply to negative 28 and add to negative 3, I'll use negative 7 and positive 4. Okay, so we have an x plus 4 factor in both denominators, which just means that they'll have the same excluded value. So from this factor, x cannot be positive 7. From the x plus 4 factor, x cannot be negative 4. But we also have to consider what the new denominator will be when we flip the second fraction and write the reciprocal. So the x squared minus 9x plus 14 would become a new denominator. So let's factor that and see what we get. All right. So factors of 14 that add to negative 9 would be negative 7 and negative 2. So we already have the excluded value of 7. We don't need to list it again. But this factor gives us an additional excluded value, which is positive 2. So we have to add that to our list as well. So don't forget that step for division. If it were multiplication, we would just take the two denominators as they are and not need to do a reciprocal. All right, excluded values here. Okay, so I'm adding, and in order to add these, they need to have the same denominator. Okay, so let me factor this first denominator to see what it's made up of. Okay, factors of negative 18 that add to negative 7 are negative 9 and 2. So x minus 9, x plus 2, and then my second fraction here also has the factor of x plus 2. Okay, so in order to add this, I would multiply this second fraction by x minus 9, so it had the same denominator. So what two excluded values do we get here? X cannot be positive 9 because of this factor, and x cannot be negative 2 from the other factor. So that's it for excluded values. You are only concerned about values that make the denominator equal 0. Okay, now getting into simplifying. So similarly, we're going to factor everything as much as we can, but then we can cancel out any common factors between the numerator and denominator. All right, so to factor this one, factors of 72 that add to negative 17 would be negative 8, negative 9. factors of negative 24 that add to negative 5 would be negative 8 and positive 3. All right, so I factor these out. I can see a common x minus 8 factor. The excluded values would be 8 and negative 3, but it didn't ask us for those. So that's okay. We can just go ahead and cancel our common factors. And so that leaves us with x minus 9 over x plus 3. And remember that we can't cancel x's in something like this. I can't cross those out because we can only cancel factors, not terms. So it would have to be the entire binomial in order to cancel it out. Okay, in number 6, we're looking at a greatest common factor. So the numerator has a common factor of 6. So I factor that into 6 times the quantity x plus 3. And then my denominator has a common factor of 3. So I would factor that into 3 times x squared minus 9. And notice x squared minus 9 is a difference of perfect squares, a squared minus b squared. And that I can factor as a plus b, a minus b. So I can factor that further. Still have my 3, but I can factor the x squared minus 9 into x plus 3, x minus 3. Okay, so then I can see that there's a common x plus 3 factor, which I can cancel out. Remember, this is reducing. It becomes 1 over 1. And then 6 over 3 would reduce to 2 over 1. All right, so in doing that, just see what's left in my numerator and denominator. In my numerator, I just have 2 times 1, which is 2. And in the denominator, I just have x minus 3. And that's my simplified answer there, 2 over x minus 3. All right, on number 7, we're going back and using our rules of exponents. All right, so we are multiplying. Remember, we multiply fractions straight across. So if we multiply 6 times 4 is just 24. Then to multiply exponent terms, remember our rule is that we add the exponents. So x to the 1 times x to the 3rd would be 1 plus 3x to the 4th. Y to the 3rd times y to the 4th would be y to the 7th. And then in the denominator, 3 times 2 is 6. X squared times x to the 1 would be x cubed. And then y cubed times y to the 1 would be y to the 4th. So now to reduce this, reduce the numbers, 24 over 6 would reduce to 4 over 1. And then the rule for dividing exponent terms is subtract the numerators. So here, 4 minus 3 would be 1 x to the 1. So I have a 4 x to the 1. And then if I subtract these, 7 minus 4 is 3, y to the 3rd. And the denominator just contains a 1, so I don't need to write it. Okay, moving on to multiplication. So remember, you're going to factor everything you can, numerators, denominators, and then cancel common factors. All right, so for this first numerator, I could factor that into x plus 6, x minus 5. And then my denominator is x plus 6. And then I am multiplying. So my second numerator, x minus 10, that's just going to stay like it is. But my denominator, x squared minus 12x plus 20, I need factors of 20 that add to negative 12. So that would be negative 10 and negative 2. All right. So we get everything factored. Now, if we were listing the excluded values, we would have to list all 3 of them, negative 6, 10, and 2, before we canceled anything out. But since they didn't ask us that, we're going to go ahead and reduce. So these x plus 6 factors cancel out. The x minus 10 factors cancel out. And that's all. So that our simplified answer we're left with is x minus 5 over x minus 2. And remember, we can't cancel those x's because they have a number subtracted from them, not being multiplied. We can only cancel terms that are being multiplied, which makes them factors, not terms. We can only cancel something multiplying with its neighbor. Okay, on number 4, I've had a lot of questions about things like this first fraction, okay? So they look kind of similar. Obviously, one's a 16 and one's a 4, but notice the big difference here. This is x squared minus 4x. The extra variable hanging off the end tells me that x is a common factor. All right, so when I factor that, I'm going to bring x out. I'm going to factor x out of both of those terms. And when I do that, I'm left with x minus 4. Okay, the difference now in this denominator, other than the value, right, say it were x squared minus 4, notice that our second number here does not have an x. It has no variable. So I cannot factor by GCF because the first term has x and the last one doesn't. But because this is a difference of squares, a squared minus b squared, I can factor it using that difference of squares pattern we talked about earlier. So I would factor x squared minus 16 into x plus 4 times x minus 4. Now moving on to my second fraction, factors of 16 that add to 8 would be positive 4 and positive 4. So it's the same factor twice. And then I have my 2x. So now as I cancel things out, I can easily see these x minus 4 factors. And then x plus 4 here will reduce. And notice, even though there's another one, I can't cancel them out. They have to cancel 1 to 1. So because this one doesn't have another x plus 4 to cancel out with, I have to leave it. Okay, so notice what we have left. We have a 1x here and a 2x there, and I could reduce those x's. X over x reduces to 1 over 1, right? So this is just 2 times 1. So in my numerator, I have x plus 4. And in my denominator, the only thing left is 2 times 1, which is 2. All right, so moving ahead, looking at the back. Now we are dividing. So remember, to divide rational expressions, we factor them as they are, much like when we multiply, but then we have to do the reciprocal of the second fraction, and then we can multiply. All right, so if I factored this as it is, this denominator has a GCF of 4, and this denominator has a GCF of 3. So I can see there's a x plus 4 factor in both of those. Okay, and remember, if I were giving excluded values, I would list them here. All right, and then now I'm going to write my reciprocal. Multiplying by, and then I flip the second fraction. I invert the fraction by switching the numerator and denominator. So now I can see these common factors of x plus 4, and then 7x over 28x, right? 7 goes into 28 4 times, so I could reduce that to 1 over 4. The x's just cancel out, 1 over 1. So left I have in the numerator a 3, and in the denominator a 4 times another 4. So that would be 16. So my simplified answer is just 3/16. That's all that's left. Okay, for number 11, we're looking at another difference of squares pattern here. Okay, so I could factor that into x plus 6, x minus 6. X minus 3 will stay as it is. X minus 6 will stay as it is. Here's another difference of squares. X plus 3, x minus 3. Okay, so again, I would list my excluded values if I'm asked to give them. And now for the division step, which is writing the reciprocal of the second fraction and multiplying. So I'm just flipping the second fraction over. And now in terms of common factors, I have these x minus 6 factors and x plus 3 factors. So I'm left with x plus 6 and x minus 3, both in the numerator. Okay, so I would just write it as x plus 6, x minus 3 with no denominator at all, because the denominator would just be 1. All right, so number 12, another division problem, and this one has a bunch of trinomials, so we just got to factor, factor, factor. All right, here, notice it's 54, negative 54, so factors of 54 that add to negative 3 would be negative 9, positive 6. Okay, factors of negative 18 would be negative 9, positive 2 to add to negative 7. Factors of 24 that add to 10 would be 4 and 6. And factors of negative 32 that add to negative 4 would be negative 8 and 4. All right, so we get everything factored out. And then we can do the reciprocal of the second fraction. So I factored everything here just where it was, just to save space. Okay, so times, and then let's write the reciprocal of the second one. X minus 8, x plus 4, and then my numerator, x plus 4, x plus 6. Okay, so common factors, I have the x plus 4s, these x minus 9s, and then x plus 6 over x plus 6. So we lose a lot of things here for this one. All right, so my simplified answer left in the numerator is x minus 8, and in my denominator is x plus 2. That's my final answer. Okay, so the last things we looked at were adding and subtracting rational expressions. And so remember, in order to add or subtract, they need common denominators. All right, so in this problem, it's asking us to add. The denominators already match, which means we are ready to combine like terms in the numerator. So 6x minus 4x is going to be 2x. And then 8 plus 2 is 10. So I have 2x plus 10 over my denominator. And then 2x plus 10 has a common factor of 2. So I could rewrite that as 2 times x plus 5. So let's factor the denominator in case it has an x plus 5 factor. So factors of negative 40 that add to negative 3, we would use negative 8 and positive 5. So notice we have a common x plus 5 factor that we can reduce. So my simplified answer would be 2 over x minus 8. All right, my next addition problem, I have different denominators. Okay, so my first denominator can't be factored. It's just x minus 6. I'm going to separate my two fractions here. This denominator, factors of negative 42 that add to 1, I would use positive 7 and negative 6. Remember, we want our denominators to be identical. They need to match. They already match with this x minus 6. They both have that. But the first fraction doesn't have an x plus 7 factor. So what I need to do is multiply this first fraction by x plus 7 over x plus 7. That gives me a common denominator, and then I'll just distribute in my numerator. So when I distribute this, I get 5x plus 35. And I'm adding, so I don't have to change any signs, plus 3x plus 8. And then my denominator, x plus 7 times x minus 6. So all I have to do now is just combine like terms in my numerator. So 5x plus 3x is 8x. 35 plus 8 is 43. And I leave my denominator factored. Almost always you're going to see denominators like this still factored into two binomials. Okay, so our last two questions are subtraction. All right, so remember with subtraction, we have to apply the minus sign to everything in the numerator that follows it. Okay, so we distribute the negative. So these denominators already match, which means I'm ready to combine like terms, but I have to make sure I'm subtracting them. Okay, so I'm doing minus 4x, negative 4x, and positive 5. And once you apply your negative, you can then think of it as addition because you've already changed the signs. So 5x minus 4x is 1x. Negative 1 plus 5 would be positive 4. And then let me see if my denominator will factor into something that has an x plus 4 factor. So factors of negative 36 that add to negative 5 would be negative 9, positive 4. So it does in fact have a common factor of x plus 4. So when I reduce that, that becomes 1 over 1. So my simplified answer is 1 over x minus 9. All right, our last problem here where we are subtracting, whoops, we have two different denominators. 8 over x plus 3 minus 5 over x plus 5. Totally different denominators. So to make the denominators match for my least common denominator, I will just take my two factors, x plus 3 and x plus 5, and multiply them together. I'll put them together. Okay, so then I just have to multiply each fraction by the other denominator, which is the factor it doesn't have. So my first fraction has the x plus 3 factor. It needs the x plus 5. So I will multiply by x plus 5 over x plus 5. And I will distribute. So that gives me 8x plus 40. And then on my second fraction, it has the x plus 5 factor. It doesn't have the x plus 3. So I will multiply by x plus 3 over x plus 3. Again, distributing. And notice because I'm subtracting, the best thing to do is go ahead and apply that negative to the 5. And think of it as plus negative 5 times x plus 3 rather than minus. So when I distribute, I'll distribute a negative 5. So negative 5x minus 15. Then I just have to combine my like terms. So 8x minus 5x is 3x. 40 minus 15 is 25. And my denominator remains factored, x plus 3, x plus 5. And that is my final answer.